All right, this is lesson 1.6 in algebra. Relations. Okay, not a lot of arithmetic in this particular lesson. More of getting you used to seeing and doing math here. All right, let's talk about this. Let's talk about the coordinate plane. We've done this before, okay? I'm going to make sure we all have this down. All right, the coordinate plane, that's this guy, right? That's this guy here, right? On the ends of these things, it is arrows, right? Okay, some basics. Some basics. What is that thing right there called? Raise your hand. What's that called there, Jonathan? Sorry, Big John. That's the y-axis. Absolutely, that's the y-axis. What is this guy here called there, Dizzy? That's the x-axis. Good. What is that point right there, that center point right there called? What's it called, Cinder? What's it called? Jem? No. What is that one specific point called, Lou? The origin. That's the origin. What is the origin? What is the point of the origin? 0, 0. Right? We'll come back to that in a second. Okay. What's this whole thing called again? What's this whole thing called? The coordinate plane. Very good. And the x-axis, y-axis. What is this quadrant here called? What's this big guy out here called? What quadrant is he? He is 1. Which way do we go when we start numbering these? Counterclockwise. This one's 2. This one's 3. This one's 4. Does that make sense? Just remember that. You don't need to know that right now today, but, well, you might. Anyway, okay, knowing that stuff. I'll rewrite it. Much nicer and much neater. Okay. Let me get one here. Try and get them. No, that's not good enough. There we go. All right. If I want to show you a specific point on here, okay, if I want to show you a specific point, we'll say this point right there. How do I show it to you? What am I going to use to illustrate that point? What's it called? What am I going to use? That's the layman's term for it. Yes, coordinates, but what is it called? I'm going to use, when we did the origin 0, 0, what's that called? An ordered pair. I'm going to use an ordered pair. Inside of any ordered pair, we do the x first, then the y. Makes sense? Where it lands on the x-axis, and then we put where it lands on the y-axis. That's an ordered pair. Ordered pair. Okay, ordered pair, x, then y. Now, knowing that, so then we go x and y, this point, written as an ordered pair, where does it land on the x? Right here, agreed? It lands on the x right there. What point is that? That is 4. On the y, where is that? That is at 2, right? So then the ordered pair, that point is 4, 2. Makes sense? The coordinates you'd say is 4, 2. You'd say this right here, that is an ordered pair. All right? If we have a set of ordered pairs, okay, if we have a bunch of ordered pairs, a set of them is called a relation. Okay? A set of them is called a relation. So if I was to go up here and give you, the points 2, 4, 3, 6, -4, -2. If I was to do that, These three right here, these 3 points, they make up a relation. Does that make sense? They are a relation. All right. I'm going to show you now how to make what is called a mapping. Okay, a mapping. A mapping looks like this. It looks like this. You have domain and you have range. You ever heard those words before? Yes. The domain and the range look like this. The domain is all the numbers that deal with x, and the range is all the numbers that deal with y. Okay, so in our ordered pairs, the numbers that deal with the domain are that guy, and that guy. Does that make sense? They're the x's. Are you following me here? This is new, I would think. So I would think you'd really want to pay attention because this is brand new. And you know what your homework's going to be on today? Yes. So you might want to pay attention. So then this is what you do for the domain. You would write down the domains 2, 3, -4. For the range, that is all the numbers that is dealing with y. So we have 4, 6, and -2. What we're doing here is this. All you're going to do is this. This is 1.24. There's 1.36. There's 1.4, -2. It's that simple. Okay, that's how you do a mapping. Sometimes, if I was to add one more range, or one more coordinate up here, I'll add one more, and I'll make it be 3, -8. One more. So then here we go. Our domains are 2, 3, and -4. That doesn't change, right? Even though there's another 3. I've already got it up. I already have it up there. The range is 4, 6, -2, and -8. This is how you would do it. You're still going to draw arrows to show the coordinates. So it would be 2, 4, 3, 6, 3, -8, and 4, -2. Does that make sense? You're still looking at all 4 points, at all 4 coordinates. Make sense? Okay. Now, let me see what they want us to do here. The other thing that I could have you do is so that's how you draw a mapping. With our 3 points, or with our 4 points, I'll put the other point back up there. The other point is 3, -8. Okay, with these 4 points, I could ask you to graph them on the graph. Yes? Let's graph them. 2, 4, that is right there. Oops, that's not 2, 4. 2, 4 is right there. 3, 6. 3, 6 is right there. -4, -2 is right here. And then 3, -8. 3, 1, 2, 3, 4, 5, 6, 7, 8. 3, -8. There is our 4 points. Agreed? This is another way of illustrating our relation, right? One way to illustrate your relation is by drawing a mapping. That was the domain, range, the arrows. This is another way by drawing it on the coordinate plane. Following me so far? You're just following this. Okay. Now, let's go to the next thing. I want you to do this for me, okay? You're going to practice this right now. Look, example number 1 at the top. It says express, and then here they are. 2, 5, -2, 3, 5, -2, and 1, -1, -2, as a table, a graph, and a mapping. Do you remember how to do a table? Okay, a table, you do. A table is this, where you put x and y, right? X and y, and then what is the first point? 2, 5, -2, 3, 5, -2, and -1, -2. That's another way of writing this, right? In a table, you've done that. So I'm going to have you do it. I want you to do all of them right now. make a table, show me it on a graph, and do a mapping right now. All right, here we go. Let's do them all. The table I just did, right? That's this guy. The table should look like this. X and Y on the top, X on the left, Y on the right, and then you just fill it in, the points, the coordinates, right? Does that make sense? Each one of these is each coordinate. That's making a table. What's another way of illustrating a relation? Is a mapping, right? And that is the domain and the range. Underline. The domain would be 2, -2, 5, -1, and 5, 3, -2. Do I need to write down -2 twice? In fact, you should not. The domain, 2, 5, -2, then it goes like this, right? Makes sense? Makes sense? Okay. How many of you have that? Okay. The last one is for us to actually graph it on the coordinate plane. That would be a 2, 5 here. That would be a -2, 3 here. A 5, -2, 5, -2, and a -1, -2. So that's simple. Make sense? Question?
On the domain range, so then it's wrong to put -2 twice?
Yes. Don't do that. Everybody following this? Everybody understand what to do with all three? I mean, it's not difficult, but you have to be able to do this for future stuff. Okay? What about this then? Let's do, let's look at this. Look at the top of page 40. In a relation, the value of the variable that determines the output is called the independent variable. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. The domain contains values of the independent variables. The range contains the value of the dependent variables. What that means is this. Do you remember, and I think we talk about functions, like, is it next? Yeah, good. We'll talk about this more tomorrow, but remember the box I've talked to you about, what goes in, something comes out? Remember us talking about that a little bit? What goes in is the independent variable, right? It's the is that right? The independent, yeah, the independent variable. It's the x. We'll talk about that more tomorrow. I'm not going to bring that up yet. That's fine. Let's do this. Let's take a normal everyday stuff here. Look at the first sample there at the top where it says identify the independent and dependent variables for each relation. Dance. The dance committee is selling tickets to the fall ball. The more tickets they sell, the greater the amount of money they can spend for decorations. What's the independent one and what's the dependent one? I usually generally like to think of the dependent one. Which one depends on the other? Which one depends on the other? You go, well, how much is it? How many tickets you sell or how much money you have? Which one depends? Barbie? How much money you have depends on what? How many tickets you sell. Do you understand? So there you go. The dependent variable is how much money you have. How many tickets you sell is the independent variable, right? How much money you have to spend has nothing to do with how many tickets you sell. But how many tickets you sell has everything to do with how much money you spend. Does that make sense? Let's look at the next one, movies. Generally, the average price of going to the movies has steadily increased over time. The average price of going to the movies has steadily increased over time. Which one depends on which? Does the price depend on the time, or does the time depend on the price? Do you understand what I'm saying? If as we move forward, it's getting more and more expensive to go to the movies. Which one's the one that depends on the other? Does time depend on the money, or does how much money it costs depend on the time? Sladen. Right. How much money it costs depends on what year are we talking about, right? It depends on, if we're talking about 1950 when it costs 10 cents to go to the movies, or are we talking about the year 2100 when it costs $175 to go to the movies? Do you see what I'm saying? Over time, it costs more money to go to the movies. Which one depends on the other? That's how you decide when it's the written stuff. That's how you decide which one is the dependent, which one is the independent. Which one depends on the other. Make sense? That's tough. It's kind of tough. You got to wrap your brain around it. Okay, what about 2A then? Let's do a sample. 2A, the air pressure inside of a tire increases with the temperature. The air pressure inside of a tire increases with the temperature. Which one depends on the other? Which one depends on the other? Salt. The pressure depends on the air, on the temperature, right? You go, well, what's the temperature? I have no idea. Well, what's the air pressure? Oh, well, it depends on what the temperature is outside. Does that make sense? 2B, as the amount of rain decreases, so does the water level of the river. As the amount of rain decreases, so as it rains less, so does the water level of the river. It becomes less too. Which one depends on the other? Does how much water is in the river have anything to do with how much rain there is? Does it affect the rain? Does that affect the rain? No. Does how much it rains affect how much water there is in the rivers? Yes. Which one depends on which then? Which one's the dependent variable? Which one depends on the other? The river, if I said, how much does it rain today? Or how much is it going to rain today? You can't know that by looking at the river. But if I said, how much has it rained? If I said, how full is the river? You could say, oh, well, it depends on the rain. Does that make sense? So then the dependent variable is the river. The independent variable is the rain. Make sense? Okay. Let's look at example number 3, analyzing graphs. Here's the deal about graphs, people. Graphs look like this. Here's a very crude one. Time travels from left to right whenever you're doing a graph, right? And so if you see a graph that is doing this, that means that it is increasing. Over time, it's increasing, right? Time travels this direction. So it started out here at one point in time, and as we move this direction in time, what's overall happening? It's going up, it's increasing. Does that make sense? If I have this and you see this, what's happening? It's going down, it's decreasing. We read it from left to right. So, here's what happens though. Let's talk about this. Here is a, let's just say that Kermit rides her bike to school. Okay? Kermit rides her bike to school. And this is her bike riding during the day. Here is 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11, 12, 1, 2, 3. Oops, 3. Here's the deal. Here's your bike ride today. It went like this. Explain to me what happened here. Why is it that it's going up from 7 till 8:30 and then it's flat until about 3 o'clock and then it goes up again? Can you explain the graph? Explain it to me, LJ. Right. So what is going on here? This is the distance, right? This is actual distance. You don't even need to know exactly how far the distance is, but you can see that from 7 o'clock until 8:30, what was she doing? She was riding her bike to school. At 8:30, she stops and doesn't start again until about 3, and then she starts to drive again. Does that make sense? You have to be able to look at these graphs and kind of figure out what is going on here. What do these things mean? What about this? I'm going to give this graph to you. You explain it to me. This is money made selling cookies at school. Okay, that's what that is. And over here I have Sunday. No, we'll do this. We'll go Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And here we go. This is what it was. You ready? This is what it goes. It goes like this. Oops, stop it. No. Explain to me what happened here. Just ballpark what happened. Just tell me. So here's the deal. From on Monday and Tuesday, they made some money, right? They were making money on Monday and Tuesday. Agreed. Making money here. They even made a little bit more money here, right? Because it's still going up. They made a lot of money here, still going up. Made some money here, going up. Made some money here, going up. Suddenly, it's flat. Why is it flat? Why? Tell me the story behind this. Why? Because there's no school on Saturday and Sunday. You see it? You see what I'm saying? On Saturday and Sunday, they didn't make any more money because there's no school. I would assume that if we were to continue this for another 2 weeks, what would happen? What would the very next thing be? What would the very next thing be? It would go up again. Why? Because what day is it? Monday. Does that make sense? You just have to be able to read these graphs, look at them, and there's no specifics here. But you should really explain and understand what they're talking about. And, oh, that makes sense. That's why that is because, oh, it's the weekend, etc. Make sense? All right. I'm going to give you guys your homework. It's not super difficult. I shouldn't say it's not difficult. It's not long.